Example, we will determine if g of x is continuous or not at x is equal to 1. Now, the g of x is equal to 3x squared minus 4x plus 1 all over x minus 1 if x is not equal to 1 or 1 if x is equal to 1. Now, we knew that the first step to take this one is the g of c, which is at x is at exactly equal to 1. So the g of c is g of 1, which is equal to 1. So the g of c exists. Next is the limit of the function. So 3x squared minus 4x plus 1 over x minus 1. We will use the first equation to determine the limit of the function, since um, we will use this function to determine the value of the limit in the left side and also on the right side of the function. So the limit of the function, 3x squared minus 4x plus 1 all over x minus 1 as x approaches 1 negative. So um, okay, by direct substitution of the value of 1 to the values of x, it's a 0 over 0, so it's indeterminate form. So the only way to get the real value of the limit is through factoring. So the factor of 3x squared minus 4x plus 1 is 3x minus 1 times x minus 1, and then over x minus 1, so we could cancel x minus 1, the factor. So 3x minus 1. Okay, so we will use this one. So the limit of 3x minus 1 as x approaches 1 negative is equal to 2. So the limit of the function in the left is equal to 2. Since we will use the same equation for the right side limit, so we also expect that the limit at the right side is equal to 2. Therefore, the limit of the function is equal to 2. So the limit exists and the g of c exists. Okay, for the third condition, the limit of the function is equal to 2 while the g of c is equal to 1. Therefore, the limit of the function is not equal to the g of c. So it is discontinuous at x is equal to 1. But what type of discontinuity? This is a removable discontinuity because the limit exists but the g of c is not equal to the limit of the function. Now, since this is a removable discontinuity, the function has a removable discontinuity at x is equal to 1, therefore we can fix the discontinuity of this function. Okay, by looking at the graph of the function, we could see that the function is discontinuous at x is equal to 1 because the limit exists, which is equal to 2, but the f of c is equal to 1. So our function is discontinuous at x is equal to 1, and we call it a removable discontinuity. So note our g of c is equal to 1 while the limit of the function is equal to 2. So in order to fix this, so there's a remedy on a removable discontinuity by redefinition. We will let our f of c equals to the limit of the function. So we will let our g of c equal to the limit of the function. So the g of c is equal to 1. So we will redefine it and we will let the g of 1 is equal to 2 or the limit of the function. So now there's a redefinition happen. The g of x is equal to g of x if x is not equal to 1, referring to the whole function of g of x, and 2 if x is equal to 1. So now the problem has been resolved. This is the new graph where at g of c, the new value is equal to 2. Okay, consider the function x squared minus f minus 5x plus 4 all over x minus 1, and then remove discontinuity by redefinition if possible to make f continuous everywhere. Since our function is a rational function, we must take note that if our denominator is equal to 0, that's the time that our function is discontinuous at that point. So we will determine on which value of x where the function is discontinuous. So we will take the denominator, x minus 1 equal to 0. So x is equal to 1. So our function is discontinuous at x is equal to 1 because 1 minus 1 is equal to 0. So anything that whatever the value of the numerator, and as long as the denominator is 0, this is undefined. So it also means that the f of c is undefined. So if we take the value of x, which is equal to 1, the f of 1 is equal to 1 squared minus 5 times 1 plus 4, which is equal to 0, and 1 minus 1 is equal to 0. This is undefined. Now for the limit of the function, since this is 0 over 0, this is an indeterminate form, we can take the real value of the limit by factoring. So x squared minus 5x plus 4, its factor is x minus 1 and x minus 4. Over x minus 1, we could deduce or cancel x minus 1, leaving x minus 4 on the equation. Now, the true value of the limit of x minus 4 as x approaches 1 is 1 minus 4, that's negative 3. Now, since the limit of the function is equal to negative 3 and the f of 1 is undefined, this is a removable function, a removable discontinuity rather. So it means that we could fix this one through redefinition. So again, our f of 1 is undefined. The limit of the function is negative 3. So for the third condition, the f of c is not equal to the limit of the function. This is our function is discontinuous at x is equal to 1. Specifically, this is a removable discontinuity because our limit exists. Now, in order to fix this one, the f of 1, which is undefined at first, we will define it. In what way? We will have the redefinition and we will let f of c equal to the limit. The limit is negative 3. So we will let the f of c or the f of 1 equals to the limit or equals to negative 3. So limit of let f of 1 is equal to negative 3. So the new function is f of x is equal to f of x if x is not equal to 1, referring to our original function, and negative 3 if x is equal to 1. Okay, question. At which values of x does the function is having a removable discontinuity? A, x is equal to negative 2, b, x is equal to 0, and c, x is equal to 3. What do you think is the answer? Okay, if you answer letter A, that's wrong. Because at x is equal to negative 2, we could see that the function is continuous at x is equal to negative 2. Now, we are looking to a discontinuous point of the function. If you answer letter C, still this is wrong, since we are looking for a removable discontinuity. Now, according to the conditions in the removable discontinuity, a function must have a limit that exists. Now, for x is equal to negative 3, we can see that the limit does not exist. So this is not a removable discontinuity. The answer is letter B, x is equal to 0, because we can see there's a discontinuity at x is equal to 0, but the limit exists, which is equal to 3.